DraftScience video. Okay, unprepared again. Don't know where this will go exactly, but I figured I'd read the one comment on the last video. It's, somebody goes to the trouble to write a whole pile of crap, I might as well respond to it. More stuff about Tesla, but I think it's going to be just more about the bigger picture, and in the context of what's the actual mechanism. So that's sort of what I want to get to. And explain keywords for this video, I think, are going to be conservation. The idea that if you create order someplace, you're creating disorder someplace else, or something like that. The idea that the yin-yang thing, if a bunch of stuff goes right, then somewhere a bunch of stuff is going left. That you can't, it's no free lunch in terms of how the mechanism overall works. And then the other word is probability. That over time is when you, over permutations is where reality manifests. So the minute scale of the universe, let's say there's 1 million of these little quanta arrows in an electron, 1 million of them. And it's probabilistic that the shape or the form of the electron is maintained just because the volume overwhelms any chaotic, like if 5 heads in a row happens, so to speak. It can't destroy it because it has such a density of pattern. The pattern is too deep, and so it has durability. So that's another key word. Better write this down, right? So durability. I've said that one before, but that's really what this is about. And the durability is merely a product of surviving the probability of the worst case, the unusual case. Yeah, surviving the unusual case defines probability. Durability. What was the other word? Yeah, I know there's another one. Conservation. Okay. So anyway, getting you well, I shouldn't have to say it because the only people watching this video probably have heard these stuff before. But anyway, the universe is just this gigantic field of directional BBs. So it can just be thought of as little bits of mass. So a mass of 1, the smallest mass, can't be divided. It's just the BB. BBs never get any smaller. So they bang into each other, and it's completely kinetic. There's no losses. There's just direction exchanged. Nothing else happens except time in these interactions. So I would argue that interactions that are at 90-degree angles, let's say, something like that, some angle less than directly into each other, those interactions are free. They don't take any time. But the ones that are head-on take the Planck 1 of time. So that's your 1. You have a 1 of mass in each quantum bit, each BB. Then you have a 1 of time that happens each time there's a head-on collision. It takes 1 time for that to happen. The universe, the instantaneous is slowed down when there's a head-on collision. So anyway, I don't know if that's an important for this discussion or not. Well, anyway, so this is the cheap diagram, and I'm going to have to make a much bigger diagram because I want to use it to explain gravity and all this other stuff that's going on. But the basic idea is these arrows get consolidated. So we could call this an electron, this consolidation. And what happens in the consolidation is, as you can sort of visualize here, as these things get closer together, these things would get further apart, because as there's a conservation of space. So as the space narrows between these, it gets wider between these because there's obviously less things out here than there are in here. So that's one kind of conservation. But obviously it has an inverse effect in that as more of these BBs get consolidated into what we call elements of matter, electrons, protons, neutrons, quarks, whatever, they, this space is essentially, as Einstein might say, is dilated, is expanded. So space stretches between out here as space consolidates in here. As more quanta, as more BBs get caught up in tighter and tighter relationships, the field that they came from has to be spaced wider and wider because there's less density in here and more density in what we call matter. So that's one style of conservation, and the inverse, the irony of it is that there's more interactions in here than there are out here. So as matter exists, interactions happen more often than in empty space. All right. So the argument I'm making is that in anything's formation, it's changing all the time. And all these little arrows, if you add all of them up, all these little indications of a directional movement, there's a net effect where, if you add them all up, there's going to be an arrow in a direction going some way, in that there'll be an imbalance. And something can be stationary and purely stationary in the sense that it has no imbalance. But whatever state it's in, it's going to tend to maintain that state. Because you can sort of understand that to have if let's say it had 10 extra arrows going in this direction, and so it had a velocity in that direction overall, because it has extra, its pieces are through the permutations of constant change, all these little bits, they constantly change 10 in this direction. It would maintain that pattern, even though at any 1 second it might have the exact opposite pattern. Overall, as you count the seconds off, its probability is going to be in that direction, because if it consumes direction in another direction from this random field, if the random field pushes it 5 times in the opposite direction, that means there had to be a 5-time imbalance. And just like flipping heads and tails, if you flip them long enough, the percentage of difference between how many heads you got and how many tails you got, that percentage will just keep getting smaller and smaller and smaller. It'll never become 0, but it becomes an infinitesimally small number as you expand the probabilities, the number of permutations. So you can imagine that in 1 second there's billion permutations inside this blob of 1,000,000 directional vectors. So, just trying to do that kind of math, you're talking like trillions of permutations. And in those trillions of permutations, the margin for aberration, the percentage of aberration becomes very, very, very small. And so whatever it starts as, it'll end up finishing as over time, because no matter what unequal movement it gets in one direction, the conservation principle will kick in, and it will get knocked back the other way. So if it gets 5 extra going this way in the first millisecond, in the second millisecond it's likely to have 5 going the other way, and so we'll end up with a net equal. That's what the chaotic field is. So this field is always imposing an equality on the thing. And what changes that equality is, like I said, if you have another thing in this picture, then this thing will be blocking, it will be absorbing influence. And so then we won't have chaos anymore. We won't have a balance field. You'll have a field that's imbalanced. So you'll have a constant, inevitable stream of influence more in one direction than influence in the other direction. And that will probabilistically push the two things together. So that's the principle of the whole thing. I've been over this before, but it's this idea of blocking. Since these are all straight line vectors, nothing can move in a curved line. Everything's basically shadowing. If you put any two things in this field, they will end up absorbing some element of the field, and in absorbing that extra by the blockage from the other. And again, it has to be induced. They're not always blocking. Obviously, this thing sitting here all by itself isn't blocking in all these directions. Stuff is still going through, quite regularly. It's only when the average inside of this changes from going, say, this way, because it gets pushed this way. So once it starts moving this way and it's absorbing more arrows going this way, then less arrows can be going that way on the thing it's affecting over here somewhere. And so it's an induced, gravity's an induced force. Like magnetism induces electricity, and like electricity induces magnetism, gravity is induced by the fact that something has to actually gain velocity moving towards you, gain acceleration, has to be accelerated to actually create gravity. It doesn't have it until it actually moves towards you, and once it moves towards you, it creates the gravity. So it's like when something comes into something's gravitational influence, it's always in its gravitational influence. It's never like stars billions of light years away are gravitationally influencing us, but it's just very weak. But as soon as it does create any influence and there's any effect, the effect just keeps multiplying as the things gain acceleration towards each other. So once the acceleration happens, once the thing moves a little bit, that creates more impetus for the other thing to move a little bit, and then this thing moves more because that thing moved, and they end up just feeding each other's acceleration. Yeah, that's probably a decent way to say it. So, but this is the liability of trying to draw a diagram that simplifies something that's a million deep. I can explain to you that every bit, every one of these quanta BBs inside matter doesn't have any location that's permanent. It's always moving in all kinds of erratic ways based on the chaos that keeps moving it, so to speak. It keeps changing its identity, its place. So one minute it's going this way, the next it's going this way, the next it's going this way. So it has a very erratic jitter. But probabilistically, that jitter will never take it far away from its original position, its original configuration. It'll always come back to that more often, because by merely being that, it means the field contains one less of that. So if you sort of think of it that way, that if I'm a up arrow, the field that I exist in has to be minus one up arrow. And so over a very long period of time, that minus one up arrow would mean I would have the field would be imposing on me a plus in this direction, a plus one in this direction. So there's a plus one destiny that exists in the field that I exist in, because I'm using the one going up. And by using that, I've denied the field one arrow going up, which means inevitably I will be hit by an arrow going down. It's like I start off with a coin that says heads, and by essentially doing that, I've guaranteed the tail will show up to compensate for that head, because it's in the field. Because the field has always this balance, this conservation. So I tried to work that through with numbers, just creating a field of numbers that's all equal. There's the same number of ones as there are twos, as there are threes, blah blah blah. And so you could say a pattern like a 7-3 would be, let's say, opposites in a clock that only had 10 hours on it. the 7 and the 3 would be kind of the opposite. So that 3 would be the going up, the 7 would be the going down. And what automatically happens to this field is that it's minus 1, 7 and 1, 3. So it's balanced as long as these two stay together. But if the 3 is released, then there's going to be 1 minus 7, so one less thing going, say, up, and one more thing going down in the field. So you can sort of get it that the numbers always have to add up. So if I let the 3 escape, there's going to be the extra 3 in the field compared to the 7. So there'll be more stuff going down than there are stuff going up, and eventually there'll be this rebalancing back to the original condition, or the condition of balance. And so when matter is formed and it has absorbed it has a velocity if something's moving, then it has this extra that's been put into it, but it's functioning inside a field that's can't destroy it because it's too deep. It's trillions and trillions of quanta deep, and so the propensity to maintain that imbalance will be kept, because even if there is an aberration in the chaos and it does impose extra in some direction, that extra will be compensated by a return to balance. And so the net effect is going to be, if I have velocity, I'll keep it. So that's sort of what inertia is. That's why things that are in movement keep moving until there's some imbalance in force that stops them, that reverses it, that creates a new acceleration. Alright. Yeah. So, I mean, I wish it was, I wish there was a way to simplify this, but there really isn't. I'm going to have to keep going through it. But again, this is only a two-dimensional. I'm only dealing with up, down, and left, right. And obviously you have to do the forward-back thing. You have to add the third dimension. And so when you make it three-dimensional is where I think you create the possibility of creating the polarization, the orientation that creates that creates the opportunity for magnetism and electricity. They're just manifestations of the same force. It's the same arrows that electricity is made out of, and magnetism is that force being energetically filtered. So chaos comes in and order goes out, kind of a way of looking at it. The polarization is extreme, so all the things coming out of one end of the magnet are all going this way, and all the things coming out of the bottom of the magnet are going that way, and that's what's creating the lack of balance that creates a opportunity for a difference in force effect, the effect of the force. Alright, that's probably enough of that. So that's a premise just to say the universe is material, it's made out of things, it's quanta, and waves are just something that's happening in the medium that is those directional arrows. They're just like a photon. They're things with a specific period, things with a pattern, and it's a pattern of magnitude. So there's more of something in this, in some arrangement here. In any one bar here, you could end up with, 1, 1, 1, 1, 1, everything moving in the same direction. Those patterns can be created once you create this matter thing, and once the matter thing can release arrows at a specific period because of the function, the shape of it, the way it's moving through space. Again, it's all jittering, so that's a really important thing to understand, is the jitter, the Brownian motion, as Einstein, I guess, put it. The jitter, it goes all the way to the quanta. The little bits of space, the little BBs, are jittering in the sense that they're constantly colliding and in those collisions, they constantly are changing direction. So if two things hit each other, you know, we're back to this X thing. You know, if the two come in this way, the two leave going this way, and what really happened was this got its direction changed, and this got its direction changed, and that's the nature of this idea of jitters. If you just follow one of the BBs in its actual movement, you'll see that it's constantly moving, but the point is that it will constantly, because of the balanced issue, end up in a position similar to where it started eventually. The jitter will always be even and proportional and eventually, and so it constantly will have this erratic movement, but the movement will always take it back to its original position, in the sense that if it gets pushed down 3 times this way, the other 3 are going to show up eventually. So if it gets 5 heads, the 5 tails will show up, probabilistically, because the field has them in it, and they will eventually show up. So the field is balanced, unless there's something else in the field, of course. Again, all these little things influence the field. All the stars are influencing the field we're in, but the influence is very, very small. Alright, so we don't gain much acceleration. Yes. So, but that's the real conservation thing, is what's really, it's a conservation of position and conservation of directionality. If I arrive in the universe as an arrow going up, I might change into a lot of other things, but probabilistically, I'm always going to be forced back into an arrow going up. So if I spend 100 moments existing, I might spend 98 of them in all kinds of different directions, but I'll spend 2 in one direction. And so that I'm always going to be in one direction more than I'm going to be any of those other directions forever. There's a balance to the conservation. And that's sort of what's happening with matter, is you can't move it one way without moving some of it, some element of quanta, some mass of quanta, in the other direction. The imbalance will have to exist in the field. If you absorb a bunch of arrows which accelerate you in a direction, there will be arrows in the field now imbalanced, in the sense the field won't have those arrows, and so there'll be more arrows going this way in the field, and so the field will be applying the arrows in the opposite direction from the arrows you took, essentially. I'm saying opposite, and I'm really just talking about every degree, you know, the average directionality. Obviously in 3 dimensions there isn't just forward, back, there's you know, there's the angles, and for each direction there's those angles, but it just makes it easier to model in your brain if you just keep it as being anything that has a component going that left, anything that has a component going right, anything component going up, anything having a component going down. So anyway, yeah. So on to this. So read some of this crap and see. But the jitter, it's important to understand that this probability thing, you know, and that it's everything is form, is something that you could find in a Planck frozen second. And those frozen moments, there's no necessary continuity, but over time there is. The probabilistic tendencies will reveal themselves, not in any one moment, but in the progression of moments through permutation. The amount of displacement, the unevenness will disappear to near zero. Alright, too many uninformed people have written material on Tesla. Yeah, well, it's hard to be informed on Tesla, right? Just because it is a lot of, there's no Tesla's point of view. Tesla didn't write any serious commentary on the big picture of Tesla. So, which has only served to diminish his accomplishments in the field of electrical power transmission. Well, you know, you're saying there's diminished, and I'm saying there's exaggerated. So, I mean, right there we're in trouble. Tesla was clearly important. Einstein was, Marconi, all these people were real. There's a lot of people doing a lot of work, and I don't know, it just seems like there's this tendency for people to say, this is the guy, and everybody else sucks. I mean, it's this whole baseball thing or something. You know, the best player on my team is better than the best player on your team. Blah, 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 blah. You know, this kind of just totally competitive way of looking at it. And yes, capitalism forced them to be competitive, and ego forces us all to be competitive in a way. So yeah, that's a natural tendency, but I'm just saying it doesn't do Tesla any service, or Edison, or it doesn't do science any service to personalize all this stuff in this way. I would argue, because there is nothing dramatically different between Tesla and Edison, in the sense they were both good thinkers who really were passionate about understanding how reality worked. They really loved that shit. And now people have made them into somehow mortal opposites, when they were really basically, in very many respects, the same man. So I just find it kind of bogus. I mean, as were most of the people working for Edison. I mean, that's why Edison accomplished what he accomplished, is because there was a lot of people wanting to do science. And yeah, the unfortunate fact is you had to somehow make that pay to make an income doing it. You know, doing raw research always had to be capitalized, and that's the tragedy of this, is that there's no organization that just puts smart brains in a mixing bowl and says, do smart things, because they all claim ownership, and they all have a sense of entitlement. You know, I suppose I would sell, for a sustained, moderate, quite survivable, comfortable lifestyle, I would certainly sell all rights to the trillion-dollar payoff. And that's just unfortunate that that's not the mechanism we have. You're either getting cheated or you're getting too much, but there's nothing like, you know, there's no fair cop to say, you know, you put your effort in. You know, look, communes just don't work, and it's just a tragedy that human beings can't make it work, because that would, in my opinion, be so much more productive if we could just cut all our egos out of it and just say we don't get any extra. You know, that there's no extra to be grabbed, and so we just make our best effort, because it's kind of a team effort. You know, to make it a team that isn't owned by somebody else, but is just owned by the team, and all the members have an understanding of a certain amount of equality in their effort. But again, that's why communes don't work, is because people don't sacrifice equally. They don't work equally. Which I might argue that, again, I would give Edison the higher praise, just because Edison didn't. I mean, Tesla was kind of spent an awful lot of time, you know, on magic tricks and living kind of a comfortable life, where Edison did kind of, you know, eat peanut butter and jelly sandwiches, you know, trying to get it to work. You know, I guess I just say I think Edison had more dirt under his fingernails, but whatever. I mean, again, I don't want to compare how much they're working either, because that's not necessarily fair. I mean, it's how much thinking you're doing, all that stuff. I'm just saying Edison was rather devoted and Tesla was rather devoted, so why can't we just say they were really both good scientists trying to do good work? And it's just unfortunate that capitalism made them enemies. He did use math. Well, I'm just saying, to say he did use math is like the other asshole saying deGrasse Tyson published papers. I mean, it's a tiny amount of math. It's a tiny, I mean, it's Newton math. It's nothing, he just didn't, okay? What he did was understand proportions and concepts. He understood how many windings of wire would be proportional to what blah blah blah, and he understood some basics like, yeah, you need a thick wire. If you're going to put 4 million watts through something, you're going to need a thick wire to do that. So he understood those kind of basics. But let's not, I mean, I'm not going to, just saying that you're not going to find a lot of math in his diagrams. The only way to work in electrical engineering is to do math. Well, I think that's just wrong. I mean, once you understand the basic principles and concepts, you understand what generates heat and a few other things, you don't need any explicit math to do the math, so to speak. I mean, you can tell that, oh yeah, well, that's got to be 4 times bigger. You know what I'm saying? It's just having, the word math implies, I mean, the simple math you do every day and understanding how wide your stride should be to keep your balance or something. I mean, that math shouldn't be called doing math. In an environment, especially now, where physics is so dominated by really obtuse and really eccentric math, and that's that math, for the context of my statement, that's the math people are asking me to do. And I don't think I need to do that to demonstrate the consistency of what I'm arguing is the reality with the existing math. Alright, anyway. Electricity is merely manipulating potential of electrons, not photons. Well, that's your argument. I say electricity is photons. It's the migration of photons between electrons. And electrons do tend to move in the direction of the electrons they're spewing or transmitting. They're dragged along. But that's all they are. They're moving much slower than the electricity is moving. The electrons are just the mechanism, the conveyor. Again, they're in this position, and a bunch of force arrows goes through them, and they eject them. And so, as that happens, they end up moving with the current, but they're being pushed by the current. They're not creating the current. And the current is something, in my opinion, that could be called a photon. It's one of these quanta. Photons are made out of this quanta. So the magnetic field is actually photons. Gravity is actually photons. They're just not photons in any kind of traditional sense, in that they have a specific wavelength or frequency. Photons are just quanta with a frequency. So the idea of a photon is not really a thing. Photon isn't really saying anything, because a photon is the same thing as, say, a graviton or a magneton or whatever you want to call those other things. And photons are just that with a frequency. So the real mechanism is this quanton. So if you're agreeable, electricity is merely manipulating potential of electrons, not quantons, then we disagree. Quantons are doing the moving. The little bits are doing the transmitting. They're the force. And the electrons are just the mechanism of conveyance. They're just being dragged along. Anyway, AC is manipulating these potentials along sinusoidal waveforms rather than dummy full cup to empty cup like direct current. Well, but I don't know if that's a great way to describe it. I mean, AC is just doing this, where DC is doing the full circle. Okay, so it's the linear stream versus just washing the machine, washing the agitator in the washing machine going back and forth versus going all the way around. Yeah, it's DC is a linear stream, one way and the other way, and AC is just agitation of the stream. That's the difference. And I would argue that to these quantons, they don't care. They don't care. Going back and forth is just as easy as keep going in one direction. So they're totally, they don't care. But what does matter is this, this kind of action, and the circular action is different in terms of how that changes the relationship between things and whether the structure can be held together. So the structure is held together by a certain balance of oscillation, a balance between two things. And if that balance is broken, then the thing will fall apart. So I think it is important in that sense. But So certain matter, certain materials would like DC current more than AC current, and other materials will like AC more than DC. Anyway, alternating current can be thought of as reciprocating, while direct current is linear power transmission. Yes, well, I know that quite well. Thank you, but yes, I already know that. Edison obviously was the one not using math. Well, I didn't claim that Edison used a lot of math either. I mean, look, back then it was all kind of hands-on. They didn't even have that much reliable math. And so it was just basically trial and error. I mean, that's how the light bulb was invented. Edison wasn't doing math. He was just sitting there doing trial and error to find out there was some way he could make a material that could transmit this energy, release as many photons as possible without getting too damn hot. You know, not without the waste of heat. Even when it came to efficiency and economics. Well, I don't know why you're bringing that in here. To say that Edison didn't understand economics would be kind of silly. I mean, obviously he was constantly fighting the vagaries of the economy, and you know, he was close to bankruptcy many times, but I wouldn't call him ignorant of economics. It's just that, you know, it was a kind of, you're always betting on something, right? You're betting on your next invention to pay the bills. I mean, that just makes sense. And you're hungry. You know, you're hungry to do something more, so you just keep spending money because you have to spend money to produce new innovation. I mean, you have to pay people to try to figure something out, and it costs money, and then, you know, if you don't get a new patent or a new invention out of that effort, you're not going to be able to pay the bills in the future, kind of thing. Anyway, but to say he didn't understand any of that, I think that's just bullshit. Tesla actually proved to be the pragmatic one, though modern myth would flip that fact based on nothing more than personal idiosyncrasies. Well, again, look, the whole end portion of Tesla's life was pretty much thrown in the toilet, you know, because Tesla was unreliable. So, I mean, to say he was pragmatic, it's not very pragmatic to be obnoxious. He was pretty obnoxious. I mean, the whole, like I said, if he would have just done what he was being paid to do, he probably wouldn't have gotten any of this trouble. Especially when it came to the telegraph thing. I mean, it was pretty clear that that's what J.P. Morgan was paying for, and it was there to be done. And instead, he's obsessed with making the monster truck. Instead, all he needed was the small truck. He didn't need to go. He didn't need to do power transmission. His obligation was merely to do the transmission of information, a signal. And if he would have done that, well, then he would be. Probably in your opinion, more properly placed in history. Anyway, Tesla actually proved, Tesla never wrote an autobiography. Well, he didn't write much of anything, and that's the whole point, right? I mean, he didn't write letters that anybody, many. I mean, people didn't keep them maybe, or whatever the argument would be. And yeah, we just have so little. I mean, you have one. I guess he wrote one book on AC current or something, but didn't say much about, an overall perspective in terms of anything that could be understood, except that he like I said, he left the confused impression that he believed perpetual energy was possible, which I think is probably a misunderstanding of what he was arguing. But regardless, that's kind of a dangerous thing to be saying. Unfortunately, those who have written about his work don't really understand what they are writing about. Well, says you. I mean, I'm sure there's some authors you agree with. So they start writing about a historical figure and end up writing about Henry fucking Potter. Well, again, Tesla sort of asked for that reputation, didn't he? Wasn't he essentially doing Henry Potter showboaty crap? I mean, he'd do this whole, I mean, imagine how inefficient it was. I mean, he was blowing up generators all the time. But yeah, you'd suck up a huge amount of electricity, do this whole sparky thing, and we know all that sparky shit is impressive looking, but it doesn't really mean much, right? I mean, creating 1,000,000 volts of electricity, you know, creating fake lightning, it all looks really cool, but does it really have any practical use? No. So, I mean, he was doing a lot of showboaty Henry Potter crap. Edison was certainly rude and stupid when he burnt Tesla. Well, again, you say he was burnt. I made the argument, and you didn't really counter the argument. I mean, to say to me that Einstein brought Tesla to America, paid for it, and that he did that because Tesla was going to be a consultant. You know, yeah, Tesla's coming just to do this one thing, and he'd be paid for this one thing, a fixed salary of $40,000, which back then was $1 million. I think it's just bullshit. Tesla was just coming to America. I probably didn't, who knows how much English he spoke, or how well. And Einstein probably said something glib like, hey, Tesla guy, if you can get this thing to work, that's $1 million idea, buddy. You know, something like that. But still, the guy was an employee. I mean, you're saying he was a consultant. He wasn't a consultant. He was employed by Edison. Where do you get to be employed and then, you know, get, like I said, what guy did Edison ever hire as a consultant? Do you have a name of somebody else Edison only hired as a consultant? He could have owned Tesla. Well, frankly, he did. He did for a minute. Well, that's exactly, before he let his greed and ego get in the way. Well, somebody could argue, I think quite rationally, that it was Tesla's ego that got in Tesla's way. Tesla basically said, shit, look what I just did a great thing for the company, and the company's not giving me $1 million. I mean, I'm sure there's people in every company right now that feel cheated. You know, I mean, they say you get hired as an engineer for a chemical company, you get paid, let's say, $100,000 a year, but you come up with something that's going to end up, you know, making millions or billions for the company. Does that mean you have a right to just rewrite the contract and say, I want my cut? I mean, life is, you know, I'm not saying it's fair. I'm just saying that's the world that we exist in. And to say fucking Edison is the most evil man in the history of mankind because he exploited an employee, well, that sounds like bullshit. A gigantic pile of bullshit. I mean, if he treated every employee like you wanted him to treat Tesla, Edison would have been out of business, you know. He wouldn't have invented anything. He wouldn't have invented the microphone, you know, that's a big one. You know, the recorder, the movie projector, all that shit, because he would have been out of business. Yes, it's a bit exorbitant, but he should have put his money, oh, here we go. He did for a minute, but they agreed in a way. It wasn't $1 million bonus, it was tens of thousands. Well, again, tens of thousands back then was millions now. So I think $40,000 then would equate to $1 million now, but can't say for sure, but I think that's what it comes down to. And Tesla was given, you know, in today's dollars, he was given $150,000, which would have been over $3 million by Morgan to do the telegraph thing, and instead he tried to do I'm going to make energy go all the way from the United States to France, which was kind of senselessly ambitious. Yes, a bit exorbitant, but he should have put his money where his mouth was, as it turns out. Well, I don't know, as it turned out, you know, they both got ruined, essentially. You know, in a sense, I guess you could say that the people benefited because of this stupid competition where these, you know, where millions of dollars were pissed away in this feudal competition between AC and DC. So instead of having a mixed system where you would take advantage of both patents, yeah, it became a patent war. And that's just, I think that in some sense that's probably tragic, because I think a mixed system would be more rational. But whatever. I mean, there's huge advantages to direct current. There's advantages to AC current. But to say that one is completely right and one is completely useless is stupid. Let's see, not only could he have owned the patent to AC, he could have had many other patents, like all the different motor configurations. Yeah, well, again, his perspective didn't make that possible, just as he didn't even want to mess with, like, he invented the fluoroscope, as much as you want to say Tesla did, but Edison did. And, he played with X-rays and didn't like them. He didn't like alternating current, okay? I mean, he didn't do the electrocuting animals things just for the sake of doing it. I mean, he didn't like alternating current because of its potential to fuck up human beings. He didn't like high voltages, I think, overall. I don't think he liked lightning. I don't think it was one of his things. So that's a perspective thing. So he invested in what he was more comfortable with. And Tesla was exactly the opposite. He loved playing with the high voltages. I mean, Tesla Electric, they say he had a couple of devices that would give him a jolt every day, and he thought it was good for him. I mean, he lived a long time. He certainly wasn't cheated in that department. He could have had many other patents in different motor configurations for less than HID lighting. Yeah, all that stuff was there to be grabbed. But, I mean, you can hardly go back in hindsight and say, well, you should have, because, gee, that was huge potential in. Well, sure there was, but, these guys did pretty good. I mean, you're complaining that they should have done this or that or this. Well, they did pretty fucking good on their own, so who am I to backseat drive them? I mean, the stuff Edison did think of was, I mean, even the stock ticker thing was a pretty, that was a pretty amazing piece of hardware. But anyway, I mean, his first invention was pretty complex. Probably we would have the recognition of inventing radio immediately instead of Marconi. Well, again, Tesla had that opportunity, financed by Morgan, and he blew the opportunity. He had the chance. He was given the money to do it, and instead he half-built something that couldn't do anything. It couldn't be a telegraph, a wireless telegraph, and it couldn't be a wireless transmitter of electricity. It was just a big blob of noise-making, generator blowing excess. No one ever knew who Tesla even was. Edison would have invented the 20th century all on his own, as far as history books would have shown. Well, again, I don't think any honest history would say that. There was lots of people, lots of people worked for Edison who went on to work on their own and did great things too. And I mean, I don't like that history tries to turn it all into one man, but yeah, that's the tendency, and that's bullshit. But I kind of find it really annoying that people will talk trash about Edison when Edison, you just can't deny the guy spent time in laboratories doing the work, and people are pissing on him. I mean, it's just bullshit. Tesla did understand spectrums, and more importantly, he was working on harmonics. Well, again, that's all. Frequency is really cool stuff, and we know so much more about it now and all that kind of stuff. But I mean, that was sort of his, again, part of his downfall is that he was trying to do something in terms of understanding the mechanism that was probably beyond his time. So he should have just stuck with getting the thing to say ouch, or one word, before he got it to say complex sentences. Anyway, I don't want to, it's a obtuse reference, but it doesn't matter. Something very important to understand with alternating current systems, again, math is required. Well, I'm going to argue that what Tesla was doing was trying things and blowing things up and all that kind of shit, and it was trial and error. And you can say that was math. I'm saying it's trial and error. He wasn't theorizing mathematically possibilities. He was theorizing them as concepts and then trying to make them work out of hardware. I would disagree when you said he discovered something rather than invented something. Well, every invention is just a discovery in a sense, but I'm just saying that I think it's obvious that some are more so than others. There are the things like the round wheel was going to be invented, quote unquote, eventually by someone. It's too obvious. So I'm just saying that, there's things that are just too obvious. Now, probably, maybe no one would have ever invented the bamboo filament. If Edison didn't exist, they would have come up with some kind of metal filament. But, you know, so you can say that inventing is the unperfected discovery. So you can almost argue that that's invention. But discovering the concept is still going to be just discovering the concept. And I just don't think Tesla... Well, again, I don't think there's anything called a true invention. That's why he didn't need to create new math equations to explain it. Well, I don't think he really explained a damn thing. So right there I'd say, what are you talking about? Because I don't think Tesla explained anything in what could be termed coherent concepts. The math already existed. He just created systems to manage and control electrical forces in a new way. So did everybody else who was doing anything at that time. Everything was a new way. You know, I mean, the first motors weren't even, you know, the field was not even around, you know, around the fucking motor. I mean, they were, you know, that's one of the things that Tesla fixed. I mean, it was just so obviously stupid in the sense that they didn't even, they had a left and a right field, no top-bottom field, and so they were losing half the efficiency of the motor by not even finishing the motor. And so obviously with more work you find out what the impedance is, and you find out how long it takes for the magnetic field to be induced, and then you figure out what the possibility is of a maximum speed you can retain with a certain size of magnet and blah blah. Yeah, so I mean, but I'm just saying that's simple math. The word math I'm using, like I said, I'm not being required to. As I've pointed out, I've already established that my system of a kinetic gravity field fits the inverse square law, so that math I fit. So that's the kind of math Tesla was using, is just this conceptual math. But that's not what these people want. These people want me to do this complex probability math that has in it, built into it, all the permutation crap, and which is fine, but again, that's, you know, I don't do calculus and a bunch of this other kind of math, and so, you know, I'm not going to bother, because I don't think it's critical to understanding the concept. But anyway, he really just, but and that's the thing I would argue here, is you're saying that Tesla explained something. I don't think he did, because I don't think conceptually he understood it correctly. So, you know, Tesla was thinking that, you know, everything's doing, I mean, his ether was a dead ether, and vibrations move through the dead field. So that's where, you know, conceptually he had it wrong. I mean, he was right to think of it as ether, but he was wrong to think that the ether isn't where all movement came from in the first place. That the ether is this balanced field, this conservation field, and that anytime you can't just get it for free. You can't get vibration for nothing. It all has to be created out of an imbalance. So there's and the whole system is in the end balanced. So it's really hard to pull an imbalance out of a system you're not seeing from a bigger perspective. Well, I mean, I think we sort of know all of this stuff in the sense that we know we can only glean energy that was stored in batteries of one kind or another, and that all matter is essentially a battery, E equals mc squared. So energy is just releasing something that's sort of been stored somewhere. So you can find places where energy has been stored, and you can steal it, but you can't generate it. And he sort of thought you could generate it. It seems even those who were considered great businessmen weren't always the brightest bulbs. Well, I forgot this part. I guess I was back here. I would disagree when you said math already existed, problem long-distance transmission, minimizing, okay, here. He really just created systems to manage and control electrical forces in a new way in order to solve the problem of long-distance transmission and minimizing losses. Yeah, well, again, he didn't, conceptually he didn't understand that, because, you know, clearly the transmission thing is true. Alternating current you can use alternating current and pass more voltage through a wire, because you don't have the liability of the flux, so to speak, being created around the wire. So if you had DC current at the same voltage as you were attempting to run AC current at, it would create too big a magnetic field around the wires. So that's the liability. But by changing, flipping the field back and forth, then you reduce that as a liability. But then you have the liability that you have to use transformers to reduce the voltage, and you end up with losses there, because now you're going to create a field bigger than you need in the transformer, and so you're going to have some losses in the distribution at that point. But overall, yeah, it's just because of the hardware problem. Thicker wires cost more money, they're heavier, so anything you can use a thinner wire to carry is better. So yes, and in hindsight, Einstein would probably concede, Edison would concede that point, but there were certain advantages to DC systems, in terms of voltage control, and the fact that you can have motors at variable speeds and all of these other kinds of advantages, and you certainly see it in DC electronics. So, there were huge advantages of maintaining a DC system. But anyway, even in the generation of the electricity initially. But anyway, Westinghouse may have gone bankrupt, but still exists to this day. Well, that's not really the argument. Lots of things have gone bankrupt and still exist today. The point is that the battle between Edison and Westinghouse cost both of them a lot, and that the victory was really a victory of durability, in the sense that Westinghouse had more money than Edison. $1 per horsepower would have equated to trillions of dollars. So that's what Tesla was given. First, he was given $1 million as a bonus for his contribution to Westinghouse, and yeah, he was given this added thing of residuals, and but the company was hit hard times, and Tesla knew that, well, something's better than nothing, and the company's not going to survive. My stock isn't going to be worth anything, so to speak, if the company goes bankrupt. So as a concession to that practical reality, he had to give back his residuals. Westinghouse would have stayed bankrupt had Tesla not rescinded his contract. Well, obviously Tesla's motive in rescinding was the fact that he was trying to help a company in trouble. Okay, the idea was to save it from bankruptcy. You're saying that it wouldn't have worked because you're looking back in hindsight, but maybe if a few other little things were changed, it would have worked. So I think that's just kind of bullshit to be backseat driving that decision. It seems even, it's clearly if the company went bankrupt, the contract would have been rescinded anyway. It seems even those that were considered great businessmen weren't always the brightest bulbs. Well, again, I wouldn't even say that. I think a lot of them did very well to maneuver, maintain their viability through really hard times. The economy wasn't nearly what it is in terms of stability. It was pretty erratic in the late 1800s. Lots of dramatic changes in the value of currency, and the gold and all the rest of it were flying all over the place. So there were lots of tough times to survive. Anyway, so enough of a video. So I will, keep messing with this stuff. I'm not going to talk about Tesla just, forever. Just got on the subject of it. It's not terribly useful to my purposes. It just seems that all the people that are opposition forces to Einstein's relativity, to even the concept of light being bent by gravity, lots of these things, that the only people fighting any of this stuff are the Teslaites, unfortunately. But I can't really I really can't, what's the word I'm looking for? I can't form any alliance with what I consider to be wrong in principle. And the Teslaites, with their wave theory of matter, is just, they're just wrong. It's still it's a hard it's a universe made of hard quanta. It is quantizable. Did they use the word quantum mechanics in here somewhere? I think it is quantum mechanics. I mean, quantum mechanics can mean a lot of different things depending on how you define it. If you call it quantum electrodynamics, maybe get out of the way, lose this idea of quantizing space, and instead quantize an ether, a field. I think it's totally win. The idea of discreteness, that it does break down to discreteness, fundamental function, is the truth. And there's nothing sparky. Sparky stuff is just an expression of that fundamental property. It's not the mechanism that the universe runs on. There's no chaos in the basic function. There's no aberration in the basic function. There's no improbability in the basic function. There's no spontaneous in the basic function. It's rigid and kinetic at its root. And simple. Just fucking simple. One little BB saying, I'm going that way. And it goes there in a straight line till it hits something else that tells it, you're going somewhere else now. That's it. Really simple. Alright, until next time.